Okay, a root mean square voltage of 12.2 volt with a frequency of 1 kilohertz is applied to a 0.29 millihenry inductor. What is the root mean square current in the circuit? And what determine the peak current for a frequency of 2.5 kilohertz? Okay, so what circuit is this? First, you must identify what circuit is this. Is there any resistor, capacitor, inductor? Okay, for what I can see here, you only have the inductor. You only have inductor. So this is a pure inductor circuit. Okay, pure inductor circuit. Okay, so this is a pure inductor. So let's look at all this value. This 12.2 volt, what is this? This 12.2 volt is the voltage for the root mean square voltage. So this is the source voltage. Okay, this is considered the root mean square source voltage because it's applied. You see that the word applied means this is the voltage source or voltage applied. Voltage source, yeah, is root and it also root mean square value. Okay, so this is VRMS source. Okay, and this is the frequency. Okay, and this Henry is a unit for inductance. So this is the value of self-inductance. Okay, millihenry need to change to SI unit Henry. Okay, what is the root mean square current? So the question asks for root mean square current. Root mean square. Root mean square. Okay, and then I want to find the peak current for frequency of, okay, this one consider F2 lah for another frequency. Yeah. So now, okay, this is a pure inductor circuit. So I want you to draw out the circuit. Yeah, pure inductor circuit. Let's draw out. So pure inductor circuit. So this is the AC voltage, the source voltage against the pure inductor circuit. Pure inductor. Okay, yeah. So so this is the V source, and this is the VL. Okay, so since this is a pure inductor circuit, so we can say that the V source is the same as VL lah. Okay, because it's parallel. When parallel means the voltage is the same. Okay, V source is VL. Okay, so here we have 12.2 volt. Okay, I want to write down the VRMS source. Okay, VRMS source of 12.2 volt. Okay, 12.2 volt is also VRMS L. Is also VRMS L because it's a pure. Why is it equal? Why is it also equal to this one, 12.2 volt? Because it's a pure inductor circuit. You can say this one VRMS source equal to VRMS L. Okay. But if this one, if RCL circuit, if you have another component like resistor, capacitor, inductor, then we cannot say VRMS L equal to 12.2 volt. It's not because it is not equal to VRMS source. Understand or not? If RCL circuit, if not pure inductor circuit, the VRMS L is not 12.2 volt. It's not because okay, because it's not pure circuit. So the VRMS L is not VRMS source. It's also not 12.2 volt. Yeah, VRMS L not 12.2 volt. But because this one is just inductor and they are parallel to each other, V source parallel to VL. So V source equal to VL, or we can say VRMS source equal to VRMSL for pure inductor. So VRMSL is also 12.2 volt. But for RCL circuit, VRMSL is not 12.2 volt. It's not the VRMS source. Okay, VL is not V source. This one, be careful. I want you to be careful for this one. Yeah, sometimes don't make mistake lah. Okay. So okay, but for this question is VRMSL is 12.2 volt lah. Okay. Now what is the root mean square current? I want to find that. Okay, so how to find the root mean square current? So I think you can easily find this. Root mean square current, you can use the formula this one. You see, like VRMSL equal to IRMS XL. Yeah, VRMSL equal to IRMS XL. Like you have VRMS R is V equal to IR, VC equal to IXC, VL equal to IXL. This is the notes you should copy down. Yeah, this is the note you should copy down. You should refer to this one always. If V naught, you have I naught. Yeah, if V naught, you have I naught, everything I naught, everything V naught, everything I naught. You have VRMS, everything VRMS, everything IRMS. Okay. So if VL, then you have IXL. Okay. So I think you can find the root mean square current. Yeah, you can find. So to find that, you can use okay. So for question A, so the VRMS L is IRMS. If it is VL, so this one should be XL. This one should be XL. Okay. So I can find the IRMS. I already have the VRMSL, which is 12.2 volt, right? So I can find my IRMS. But XL, what is XL? What's the formula for XL? XL is omega L. XC is 1 over omega C. 1 over omega C. If XL is omega L, or 2 pi FL. Okay, so find that first. So XL is omega L. Omega L. So it is omega L. Omega is 2 pi F. Okay, so XL 2 pi FL. So okay, frequency is 1 kilohertz. 1 kilohertz. So kilo change to 1000, right? Exponent 3. So it's 1 exponent 3, and then L is this one 0.29 milli. Milli is exponent negative 3. Yeah, exponent negative 3. Exponent negative 3 Henry. Okay, milli Henry. Okay, so can cut. Okay, so what's the answer for this one? What's the XL for this one? So 2 pi multiplied by 1 multiplied by 0.29. So I got 1.822 ohm. That's the reactance. So I got it. So just now VRMSL is also the VRMS source because it's pure inductor. So the source equal to the L. For RCL is L not equal to source. The source not equal to L if RCL, but pure inductor they are equal. Pure inductor they are equal. So VL equal to V source. So I need the VL here. VL is 12.2 volt. Okay, is equal to V source. Equal to V source. So this is a 12.2 volt, and this IRMS XL is 1.822. Okay, 1.822. So I can find my IRMS. So 12.2 divided by 1.822. So it is 6.696 ampere. That's the answer. Okay, Is that correct? Yeah, 6.70 ampere or 6.696 is the same. Okay. Now, what about the peak current for this frequency? So for different frequency, what will happen to the peak current? So let's do it. So for B, so if you have different frequency, what will happen? Okay, if you have different frequency, then it will affect the XL, isn't it? It will affect the XL. When XL is affected, so the IRMS also will be affected. IRMS also will be affected. When IRMS affected, I0 also will be affected. Okay. So okay, let's do it. So I think we can do the second time. Find okay, I have a VRMS L. Okay, so VRMS L, IRMS XL. Okay, so when you affect the frequency, you will affect the XL. When you affect the XL, you affect the current lah. But this one is the VRMS L will always be constant. Why is it always be constant? Because is the applied voltage is always 12.2 volt because it's the amount of voltage you apply. So this applied voltage is constant. You applied 12.2 volt. It didn't say you change to different voltage. You didn't change to another source voltage. You still use the same. Source voltage. You still use the same source voltage, 12.2 volt. It's still because it's the same as V source lah. V source L. Because it's pure resistor, pure inductor circuit, isn't it? Pure inductor circuit. It's still, this one is still 12.2 volt. You didn't change, right? You didn't change the voltage. You didn't change the source voltage, so the V source is always constant. So this one is constant. Okay. So the VL is still 12.2 volt. Okay. VL is still 12.2 volt. So I want to find the IRMS, the new IRMS XL. Okay, XL. The XL is 2 pi f. 2 pi FL. Yeah, 2 pi FL. This one is F2. Yeah. The new frequency L, and then okay, write again. IRMS, so 2, and this new frequency is 2.5 kilo. Kilo is exponent 3. Yeah, exponent 3. And then L is 0.29 milli. Milli is exponent negative 3. Okay. So I can calculate this exponent 3, negative 3 can be cut off. So I can find my IRMS, my new IRMS. Okay, so let's calculate 2 pi multiplied by 2.5 multiplied by 0.29. Okay, so I got this. So 12.2 divided by the reactance. So I got the current. The new root mean square current is 2.678 ampere. Okay, that's the root mean square current. But you want the peak current. So the peak current is because I know IRMS is I0 over Z2, right? I0 over Z2. So this root mean square current is 2.678. So I0 is 2.678 multiplied by Z2. So which is 2.678 multiplied by Z2. So the answer is 3.79 ampere. Is that correct, the answer? Yes, the answer is correct. Okay, so it's 3.79. Yeah, 3.79 ampere. Okay, that's the answer. 3.79. Yep. Okay, so that should be it. Okay, remember, when you change the frequency, you just change the reactance. It will just affect the current. It will change the current. Only the reactance and current will change. The voltage will not change because the applied voltage is constant. The applied voltage is still applied 12.2 volt. You didn't apply less, didn't apply more voltage. You didn't apply less voltage, didn't apply more voltage. So the V source doesn't change. It's constant. Okay, this one is constant. So changes is only the current and reactance. Okay, so that's the answer. All right. Bye. And remember this one, for pure inductor, the VL is V source. VL is V source. That's why we can use this V source 12.2 volt straight away to VL here. But for RCL circuit, if you are provided V source is 12.2 volt, you cannot use 12.2 volt straight away for VL. You cannot straight away use 12.2 volt for VL. No, if RCL circuit is not pure inductor, you have resistor and capacitor some more. So this V source 12.2 volt is not for VL. Yeah. This if RCL circuit, if you have RCL circuit, this VRMS source of 12 which is 12.2 volt is for IRMS Z. It's not the, it's not the XL. It's not XL. It's not for XL. This 12.2 volt is not for XL. It's for Z. Yeah. Because you have RCL. Okay. But for VL, for pure inductor, it's only XL lah. But for RCL circuit, this one is Z already. It's not XL. Okay. Okay, so I hope you understand, yeah, what's happening. Okay, bye.